Hello friends, welcome to my channel. This is Objective Mechanical Part 3 for RRB, IES, PSU and State Public Service Commission and SSC, also BEL. Question is, in a multiple V-welt drive, when a single welt is damaged, it is preferable to change the entire set to option A, reduce vibration, B, reduce slip, C, ensure uniform loading, D, ensure proper alignment. Its answer is C, to ensure uniform loading. Which of the following pairs is not correctly matched? Positive drive, belt drive. This is belt drive is not a positive drive. High velocity ratio in one gearing around 80:1 to 100:1 velocity ratio in worm gearing. Then non-parallel and non-intersecting spiral gears, hypoid gears. Example is hypoid gears. Then diminished noise and smooth operation helical gears. Helical gear. Here this is the example of helical gear. One more thing is important here. In helical gear, axial thrust is present. Single helical gear. This is the example of single helical gear. So, to reduce that axial thrust, we are using herringbone gear or double helical gears. It's having zero axial thrust. This question was so many times asked. Which gear is having a zero axial thrust? Its answer is herringbone gear or double helical gears. Question is, in case of flywheel, the maximum fluctuation of energy is del E equal to maximum energy minus minimum energy. E max minus E minimum. So from option B is our answer. Difference between the maximum and minimum energy. We can write it as E max minus E minimum, E equal to half I omega square. So we can write it as half I omega max square minus. These formulas are very useful for GATE, BEL and IES examination. We can write it as I omega mean square into CS. These are very important. CS is coefficient of fluctuation of speed. Maximum speed minus minimum speed divided by mean speed. This is also very important. Coefficient of fluctuation of speed. When a helical compression spring is cut into two equal halves, the stiffness of each of the resulting springs will be how much? Our formula is stiffness K equal to 64 RQN. So here K is the stiffness of the spring and G is shear modulus, small d is wire diameter and capital R is coil radius or mean coil radius, N equal to number of turns. So in this case spring is cut into two equal halves. So N became N by 2. K is inversely proportional to N. K into N is constant. So in second case N is N by 2. So in second case K equal to G d to the power 4 64 Q N by 2. So 2 into G d to the power 4 divided by 64 RQN. So 2 times of previous one. Let it be Ki final. So Kf equal to 2 times of initial stiffness. From option C is the answer. For different types of threads, I am giving the angle. For Acme thread, it's 29 degree. Buttress thread, it's 45 degree. Buttress thread, power transmission in one direction only, or axial thrust in one direction only. This is also important. Then isometric thread and British Association thread and Seller thread, all are having 60 degree included angle. Then square thread 90 degree, and for 5 threads it's 55 degree. So in this question 29 degree Acme thread is our answer. Then this is also important, designation of threads. If they will write like this M12, then it represents coarse thread of nominal diameter in mm. If they will write like this M12 into 1.25, then it represents fine series, nominal diameter and pitch in mm. One more thing is important here, trapezoidal thread. Trapezoidal thread included angle is 30 degree. Next question, in order to have smooth operation, the minimum number of teeth in the small sprocket for moderate speed should be, its answer is 17, B. Next question, to increase the capacity of ball bearing, dash is provided to increase the number of balls in the bearing. Its answer is filling notch. Filling notch bearing is also called as maximum capacity bearing. Here we can increase the number of balls. This question was already discussed. One of the following power screws transmits power in one direction only. Answer is buttress thread. Included angle 45 degree, Acme thread 29 degree, square thread 90 degree, trapezoidal thread 30 degree. A solid shaft transmits a torque of T. The allowable shear stress is tau. What is the diameter of the shaft? We know T equal to pi by 16 tau s dq. We have to calculate the diameter of the shaft. So dq is 16t pi tau s, or diameter d is 16t pi tau s. From option A is our answer. A thin cylinder with both ends closed is subjected to internal pressure P. The longitudinal stress at the surface has been calculated as sigma 0. The maximum shear stress at the surface will be equal to how much? For thin cylinder, is greater than 10. This is the condition for thin cylinder. Di is inside diameter and T is the thickness. Then circumferential stress or hoof stress, PD, here you can write it as d by t is greater than 10. PD by 2t, longitudinal stress sigma n is PD by 4t. So sigma c is 2 times longitudinal stress. Here in this question, sigma L is sigma O. So maximum shear stress at the surface will be equal to, or maximum in plane shear stress at the surface sigma 1 minus sigma 2 by 2. Sigma 1 is maximum principal stress, its sigma c, its value is 2 into sigma L or 2 into sigma O. 2 sigma O minus sigma 2 is longitudinal stress. In this question it's sigma 0 by 2. So sigma O by 2 is our answer. 0.5 sigma 0, D is our answer. In a thick cylinder pressurized from inside, the hoof stress is maximum at the A, the center of the wall thickness, B, the outer radius, C, the inner radius. C is our answer. An open coil helical spring of mean diameter D is subjected to an axial force P. The wire of the spring is subjected to combined shear, bending and twisting. C is our answer. The maximum distortion energy theory of failure is suitable to predict the failure of one of the materials is, for ductile material, MDT is best. MDT is very important for GATE exams, also for ISRO and IES. Its graph also very important. It will come like ellipse. Here, see the ellipse. Its formula also very important in solving problems. Formula is sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. It's equal to 2 into sigma y by FOS whole square. It is also called as MDT, also called as von Mises and Henke theory. This name also important. Sometimes list 1, list 2 matching also they are giving. So formula also very important. The effect of a force on a body depends on its A, direction, B, magnitude, C, position, D, all of these. Its answer is D, all of these. Question is, two identical circular rods made of cast iron and mild steel are subjected to same magnitude of axial force. The stress developed is within proportional limit. Which of the following observation is correct? A. Both rods elongate by same amount. B. MS rod elongates more. C. Cast iron rod elongates more. D. Both stress and strain are equal in both cases. So, stress by strain equal to E. Stress is P by A. Strain is change in length to original length equal to E. So, del L equal to PL by AE, or del L is inversely proportional to E. In this question, cast iron and steel, in both cases area is same, A, load also same, length also same, and we know Young's modulus of cast iron is approximately E steel by 2. So we will use this one. Del L is, or del L into E equal to constant. So del L cast iron into E cast iron equal to del L steel into E of steel. Del L cast iron by del L steel equal to ES by E cast iron equal to, it's 2 times E of cast iron, finally 2. So from here del L of cast iron is greater than del L of steel. I have to check it from the options. Cast iron rod elongates more. C is our answer. A beam is said to be of uniform strength if, this is so many times asked in IAS, ISRO also asked, for PSU also this is very very important. A beam of uniform strength. A. The bending moment is same throughout the beam. B. The shear stress is same throughout the beam. C. The deflection is same throughout the beam. D. The bending stress is same at every section along with its longitudinal axis. This is the answer. The point of contrafracture is a point where A. Shear force changes sign. B. Bending moment changes sign. C. Shear force is maximum. D. Bending moment is maximum. In point of contrafracture, it is the point where bending moment changes sign. And there in point of contrafracture, bending moment is 0 or bending moment changes curvature. So from options, bending moment changes sign. B is our answer. A cantilever beam of length L, moment of inertia I, and Young's modulus E carries a concentrated load W at the middle of its length. The slope of cantilever at the free end is, a cantilever beam. A cantilever beam, load W at the middle, so it's L by 2, L by 2. Slope at free end, we have to calculate free end, no load, so from here it will become a straight line. let it be point A, B, C. At C point we have to calculate the slope. At C point no load, so B point slope is B, same slope at point C. For cantilever beam, slope formula is WL square by 2 EI. Here L is, length is L by 2. So slope at B equal to slope at C, WL by 2 square by 2 EI. WL square by 8 EI. This is our answer. C is the answer. Question is, in a cantilever beam, if the length is doubled while keeping the cross section and concentrated load acting at the free end is same, the deflection at the free end will be increased by how much? A cantilever beam load acting at the free end, let it be P, deflection, slope formula is PL square by 2 EI, deflection PLQ by 3 EI. Length is doubled, so L2 is 2 times of L1, keeping the cross section A1 equal to A2, P1 load equal to P2 at second case. Deflection we have to check. So delta 1, this is delta 1, then delta 2 equal to P2 L2Q by 3 EI. Only length is changing. I is not changing, E also not changing, only length is changing. So P2 L2 is 2 into L1 whole Q 3 EI. P2 equal to same P1 into 8 L1Q 3 EI, or delta 2 equal to 8 into delta 1, increased by 8 times. D is our answer. Shear force diagram for the given simply supported beam is how much? Point load. So B and C not possible. Out of A and D we have to calculate. Let it be A, B point. One kilonewton, 2 kilonewton. All are L by 4, L by 4, L by 4. So RA plus RA equal to RB. Symmetric loading. So RA equal to RB equal to vertical load is 4 kilonewton by 2. It's 2 kilonewton. RA equal to RB. Two kilonewton. So if you take shear force diagram, RB is anti-clockwise, so it will become negative. In this question their sign convention is little bit different. Anti-clockwise positive and clockwise it's negative. So it will come first 2 kilonewton, then 1 kilonewton, then -1, -2. It will come like this. 2 kilonewton, 1 kilonewton, this side -1. From here also we can answer the question. RA/RB we got 2 kilonewton. In D it's 1 kilonewton and 1 kilonewton. So this is not possible. A is our answer. This type of question they are asking in IAS. So this is very important for IAS. Thank you friends. Thank you for watching my video. Thank you.